All right, let's continue with the practice test. This in focus. All right, so the last one we did was 55. We need to do 56. I'll get this to focus for us. All right. So we want to find the degree of each vertices. That just means how many edges go to each vertex. So for A, there's 2. For B, there's also 2. For C, there's 2. For D, there's 1, 2, 3, 4. For E, there is 1. Now F has got the loop, so that's 1, 2, 3. Okay, so now we'll put that in the table. So what did we do? 2, 2, 2, 4, 1, 3. All right. The next one is, which vertices are adjacent to A? Well, this is A. And we just want to look at which vertices has a direct edge to A. And those are B and C. Okay, so B comma C. All right, 57, 58. Use the vertices to describe 2 paths that start at vertex B. All right, so that means on this option we have 2 that we're going to choose because it says 2 paths. So it might be easiest. To follow each of these. So let's see. BA, we're trying to have a path from B to F. They all end at F. They all start at B, so that's good. All right, BA, C, D, B. Oh, that doesn't work, so I'm going to scratch that out. If I come to one that doesn't work, I'm just going to scratch it out. B, C, D, E. Well, E can't go anywhere, so throw that one away. C, B, C, D, F. That works. Let's see. B, A, C, D, F. That works. In fact, that's about all I can do. I can either go B to C to D to F, or B, A, C, D, F. So yeah, that's it. Those are our 2. 59. I went ahead and did this one for you. It's just a basic definition. Number 60, identify the even vertices and identify the odd vertices. So before I work it or answer it, I think I want to just go and next to each vertex write what their degree is. All right, so A is 2. B has got this loop, so 1, 2, 3, 4. C is 1, 2, 3. D is 1, 2, 3. E is 1. F is 1, 2, 3. G is 1, 2. H is 2. I is 2. All right, we have multiple even vertices, so you must click B. Okay, if you choose only even vertex, then there better be one answer. But if there are multiple evens, you better choose the plural, which is vertices. All right, so that would be A, B, G, H, and I. And then the odd ones, right? Well, unless I were to have chosen all of those, it means we have some that are odd. So it should be everything else. Again, we have multiple ones. So C, D, E, and F. Those are odd ones. All right, 61. Consider the graph, explain why GFDED is not a path. Well, let me map it real quick. GFDED. So it would be going back on itself. We would be going from here to here to here and then back, but we can't do that. We can't go back on ourselves. So that ED is used twice. DE is used twice. All right, draw a graph with the given characteristics. It has to have 4 even vertices. Well, each option has only 4 vertices, A, B, C, D. So that means each of these has to be even. So I can just check. Guess I'll start with A and I'll go around. 1, 2, 3, 4, 5. Well, I can stop right there because if A has 5, then it's no good. Let's look at the next one. B. A has 1, 2, 3, 4. All right, good. B has 1, 2, 3, 4. C has 1, 2, 3, 4. And D has 1, 2, 3, 4. So I think that's it, but I'm going to check the others because this is a test. All right, here A is 1, 2, 3, 4, 5. All right, no good. And then D is 1, 2, 3 for A, which is no good. So I only had to really check the first one, and I was able to deduce it. Okay. All right, now I went ahead and did number 63. Determine which statement makes sense or does not make sense. A graph can be used to model friendships between coworkers and a company, at a company. It makes sense. 63, 64. I went ahead and did this one, and I circled it because, let's see, all right. I went ahead and did this one for you, but this tells us, this reminds us to review the definition of Euler circuit, Euler path, and the Euler theorem. Okay. So does a city's sanitation department is reviewing their routes by labeling each intersection as a vertex. They discover they have 46 vertices in a certain area. So since all, let's see, okay, does that area have an Euler path if 6 of those intersections have 5 roads that meet at a point? Okay, so again, you'll need to look at that. I would make maybe some note cards for Euler path, circuit, Euler theorem, and then the Hamilton paths and circuit, so I know the difference. All right, number 65 is another definition. The path that passes through each edge. See, remember the word edge in Euler, E-E. Okay, that's an Euler path. It's also another definition. A connected graph has at least one Euler circuit, which by definition is an Euler path, if the graph has no odd vertices. And if they're all even, meaning they're not odd, you can start at any. Again, this is the Euler theorem, so check that out. All right, number 67. Use the graph to determine whether the path described is an Euler path, an Euler circuit, or neither. So this is a good one. Let's first go ahead and do it. Okay, FAD. F to A to D, D to E, E to A to B, A to B, B to C, C to D, D to B. All right. Well, because we didn't start and end with F, then I know that it's not a circuit. It's not an Euler circuit. Okay. But I have also not used every edge, so it's not an Euler path either. So path described is not an Euler path or an Euler circuit. Okay. All right, number 67, 68. All right, so we have a graph on the right. Explain why it has at least one Euler circuit. Use trial and error or Fleury's algorithm to find such a circuit. Well, I think what I want to do on this one is check all my vertices because we're looking for Euler circuits. I want to check the degrees. So A has 1, 2, 3, 4. B has 1, 2, 3, 4. C has 1, 2. D has 1, 2, 3, 4. And E has 1, 2. So all my vertices are even, which means we're going to have an Euler circuit. So it has no odd vertices. So it says, explain why it has at least one Euler circuit, because it has no odd vertices. Okay, and then the second part says, write an Euler circuit starting at A. Okay. I'm going to sketch it out as I do it. I'm going to go from A and go to D. AD. All right, so I can go back to A this way. So I'll go back to A as long as I don't cross any edges. E. Then I got to go to B. And then from there, I can go to C or D. From B, I'm going to go to D. And then from there, I have to go to C. And then from there, I have to go to B. And then I go to A. All right, 69. A connected graph has 98 even vertices and 10 odd vertices. Okay, 98 even vertices, 10 odd vertices. All right, the problem here is the fact that I got too many odd vertices. All right, so really the limit was 2 odd vertices. Anything beyond that is a problem. So it has no Euler circuit or path. And the reason is because we have too many odd vertices, okay? More than 2 odd vertices. Again, I'm getting all of this from Euler theorem and the definitions. All right, let's see, we'll do a few more. Mail carrier parks her truck at the intersection shown. All right, mail carrier is here. in the figure and walks to deliver mail to each of the houses. The streets on the outside of the neighborhood have houses on one side. Okay. The interior streets have houses on both sides. Okay, it's kind of hard maybe to see the picture, but I can see it. On both streets, the mail carrier must walk down the street twice on those streets. Okay, so on these inside streets, she's got to go down those twice, covering each side. The graph that models the street is here. All right, cool. So there's our, there is our graph, and they even cleaned it up for you. So let's see here. Let's count my vertices. 2, 1, 2, 3, 4, 4, 1, 2. Let's see, D, 1, 2, 3, 4. E is 1, 2, 3, 4, 5, 6, 7, 8. Wow. Okay. F is 1, 2, 3, 4. If they're all even, we're going to have an Euler circuit. 1, 2, 1, 2, 3, 4, and 1, 2. So yeah, we're going to have at least an Euler circuit, which by definition, we have a Euler path. Okay. Lots of definitions. Just make sure you know those definitions and formulas. Okie dokie. Number 71. The layout of a city with land masses and bridges are shown. Complete parts A and B. Okay. Draw a graph that models the layout of the city. All right, so let me use my red pen. So A, B, C, D, E. So these red dots, these big points are representing my vertices. So here's what I notice. A and C are connected twice. We got both of those. So I'm thinking it's either this one or this one. But I'll keep going. A is connected to E. A is connected to D. Now C is only connected to E, and E is connected to D, and E is connected to B, and D is connected to B. Okay, so I could rewrite it, but I know it's between these two since C and A match up. And then I can check, is C connected to B? It is not, so it has to be B. If you want to map this whole thing out, you can. A, B, C, D, E. I'm just kind of putting the vertices the same way they did it. This is A, B, C, D, E. All right, according to this graph, C and A have two connections, two paths. A is connected to E, and A is connected to D, and B is connected to D, and B is connected to E. And see, notice B and C are not connected to each other. There's no path there, so it has to be B. Now, on this one, show you how this works. This one's interactive. It's going to be a little challenging to do it on the paper. We'll try it though. So it says use the graph from part A, so whatever we chose here, to determine if the city residents would be able to walk across all of the bridges without crossing the same bridge twice. All right, let's see. I'm going to look at my vertices. A has 1, 2, 3, 4. B has 1, 2. C has 1, 2, 3. I can do it with one of those. D is 3, and E is 1, 2, 3, 4. So as long as I don't have more than two odd vertices, I think we're good to go. Okay, so yes. Okay, if the path exists, it goes from C. All right, so they're having to start at that. All right, so C to A back to C. That kind of gave that away, but okay, whatever. C to A to C. Let me map it as I'm doing it. C to A to C. And then from here, I got to go, well, we know the next one after the next thing is B, so of course I got to go to E. So E. All right, E to B. And then something, and then A. Well, obviously I got to go to D. I'm giving that away. D to A. And now we got to go back to E. And then D. Oh, I mapped the wrong one. Look at that. I mapped A. A was not the answer. Let me map it on B. Sorry about that. All right, so from C to A, back to C, to E, to D, to, oh, I messed up. C to A, back to C, to E, to B, to D, to E. From C to A to C, C to E, E to B, E to D, D to A to E, and then E to D. All right, so that was a little messy. You might have to redo that, but there we go. So if you get part A right, this second part is pretty straightforward. All right, we'll stop the video on that one.